This is a typical binomial probability exam question. It states a large batch of clay pots is moulded and fired. After firing, a random sample of 10 pots is inspected for flaws before glazing, decoration and final firing. If 20% of the pots in the batch have flaws, calculate correct the two significant figures by using the appropriate binomial distribution. The probability that the random sample contains no pots with flaws. So that's part A. So in part A, we want the probability that the sample contains 0 flaws. So if we're looking at the binomial distribution, we're going to count the number of flaws, or the number rather of pots with flaws, I should have said. So x here follows the binomial distribution. What's our fixed number of trials? Well, we're looking at 10 pots each time. And what's the probability of them having flaws? 20%. So that's 0.2. And in part A of the question, having exactly no pots with flaws, I want x is equal to 0. So the formula for binomial probabilities is n choose r, p to the r, 1 minus p to the n minus r. So to work out the probability I have here will be n choose r, this is my r value, p to the r, 1 minus p to the n minus r. Anything choose 0 is 1, anything to the power of 0 is 1. So that's going to give me an answer of 1, that's going to give me an answer of 1. My only value is going to come from 0.8 to the power of 10. And if you work out 0.8 to the power of 10, we get 0.1073. And they're asking for two significant figures, so the two significant figures, that's 0.11. Part B of the question was exactly one pot with a flaw. So we're still using binomial 10 0.2, and now we want the probability x is equal to 1. So that'll be 10 choose 1, 0.2 to the 1, 0.8 to the 9. Anything choose 1 is the number at the top. 0.2 to the power of 1 is 0.2. So I do have to do the 0.8 to the 9. So I should be doing 10 times 0.2 times 0.8 to the power of 9. My calculator is showing me something which isn't right because I typed 110 in. I'll do that again. 10 times 0.2 times 0.8 to the power of 9. My calculator is giving me 0.2684. So the two significant figures, that would be 0.27. Part C, exactly 2 pots with flaws. So this is now x is 2. Just change the 1s to 2, so 10 choose 2. 0.2 to the power of 2, 0.8 to the power of 8. And again, it's a case of putting it into a calculator. 10 choose 2 times by 0.2 squared times by 0.8 to the power of 8. And my calculator here is giving me 0.3019. So to two significant figures, that would be 0.30. The final part of the question said, the batch is accepted without further checking if the random sample contains no more than 2 pots with flaws. Find the probability the batch will be accepted without further checking. So I want the number of flaws to be no more than 2. So I'm looking for the probability x is less than or equal to 2. Well, that's the same as 0 or 1 or 2. So the 0, we had an answer. 1, we had an answer. And 2, we had an answer. We've worked those probabilities out, and if I add those probabilities up, I get 0.68. And that is that question completed.